Lesson 11.6 is finding range from an equation. I thought the easiest thing to do would be to go back over parent functions and what each graph looks like, and then the rules of what changes their range, what shifts them up or down. So first are the linear and cubic. I put those together because linear equations will have a slope, that is the number in front of x, and it has a y-intercept. It's y equals mx plus b. If I'm looking at the range, all the y values, it'll always be all real numbers. So I'm just going to put that. So always all real numbers. Same thing for cubic. When I have the highest degree term as x cubed, it'll always have one end up and one end down. In other words, it'll have y values everywhere, sometimes multiple y values at a certain x. So this is also all real numbers. Quadratic makes this parabola shape, and these are in vertex form. But if I have a negative in front, that means it's flipped upside down. So it opens down. Versus this is a positive one, so then that means it opens up like normal. So if it opens down, that means everything is going to be below a point. And if it opens up, everything's going to be above a point. And then the number on the end, that is my vertical shift. So if I was looking at this graph, I would know that this went up 4. And so my inequality would be numbers less than or equal to 4. And then this one, since it's at 8, right here, and it's opening up, 8 would be the lowest, so all my, y, all my y values would be greater than or equal to 8. But you could put any of these on Desmos and just graph them and look at the graphs. That's fine. Absolute value is very similar to quadratic. It makes a V shape. Same rules apply. If there's a negative in front, it's going to be opening down. And if it's a positive in front, it opens up. And then the number, the constant number outside of the absolute value is your shift, up or down. So it went down 2. That's why its vertex is there. So I would say all y values are less than or equal to -2. This one would be going down 5, but it's opening up. So the lowest point is 5. I would say all y's are greater than or equal to -5. And then next is my exponential function. Exponential functions normally have an asymptote at x equals 0. Why do I keep saying x? Y equals 0. Sorry. This is the x-axis, but it's the line y equals 0. So then it's a question of, is the curve going to be above it or below it? And that comes again from the number, the sign of the number in front. So with this being a negative, it's down here. And so when it's down here, I would say y values are all less than 0. And on this one, since this is a positive, it's going to be above this line, so I'd say y values are greater than 0. If there were any plus or minus numbers on the end, that would just then move this asymptote up or down, but the curve would still be the same. Okay, and then we have our rational functions. We know that it has a horizontal asymptote, and it comes from this shift. So this went up 6. And so now my asymptote is y equals 6. So basically saying that everything except for y can't be 6. And then here it went up 4. The negative in front just made the curves be different quadrants, the opposite. Like this would be quadrant 1, kind of quadrant 4. Now we're 2 and we're 1 and 3, 2 and 4. Oh my goodness. And so y can't be 4 is the only issue. And then a square root always has this stopping point because x's can't be negative. But again, we're looking at the vertical shift, not the horizontal. And so this went up 1. So this function's above the line y equals 1. So y's are all greater than or equal to 1. This one I don't know if that was supposed to be, I don't think that plus. Oh, that was supposed to go all the way across. Okay, now I got it. Again, we're just looking at this number, but because there's a negative here, it got flipped upside down. And so now it's below the 3. So I would say all my y's are less than or equal to 3. Kind of confusing. If that doesn't make sense, again, just graph them on Desmos, but that's time consuming as well.